Phenomenal question to end this junior maths challenge. So, in Miss Quaffley's class, 1/3 of the pupils bring a teddy bear to school, and then we've got boys and girls taking books out. So that means the pupils are either going to be boys or girls, and the total of them is going to be B plus G. B is the number of boys, G is the number of girls. So 1/3 of these give bring a teddy. So the number of teddies is going to be B plus G over 3, which means B plus G is going to equal 3T. That's the first equation relating them without the fraction in. Next up, we're told that each boy took 12 books out the library, so in total they would have taken 12B books out. And each girl took 17 out, so that's 17G. And then each teddy took 9 books out, so 9T. And that is going to equal 305. So I can multiply through by 3 to give 3B plus 3G is equal to 9T and substitute in for this. Okay, get rid of one of the unknowns. Therefore, 15B plus 20G is going to equal 305. Now, this is a Diophantine equation because there are two unknowns, but they have to be whole numbers. That's the condition here, because obviously you can't have like half a boy or anything. Well worth looking into these if you enjoy this question and you want to practice some more. So first thing to do here is divide through by any common factors, and 5 goes into all of these. So I'm going to divide through by 5 to give 3b plus 4g is equal to 61. Now there is no other common factor. Sometimes you actually get a common factor between the right-hand side and one of the other terms, and that can speed the process up. It's not going to here. But there is something. Um, this is a multiple of 3, and so it's either going to be odd or even. The 4g is always going to be even. Therefore, it must be that b is odd, because if b is even, then this will be even, and we've got even plus even equals odd. So b is going to have to be odd. So at this point, let's just find the different possible values. So b is equal to 1, and then I'm also going to keep track of 61 minus 3b, because then I'm going to be trying to divide that by 4 as we go along. So when b is 1, we're going to get 58 here, and that is not divisible by 4, so that's not going to be possible. Let's go with the next odd number. We're going to get 3. So now I'm doing 61 minus 9, which is going to give 52. I'm basically just minusing 6 each time, and that is divisible by 4. 4's into, I'm going to get a 1, and then remainder 1, so it's going to be 13. Now that is actually an answer on the list, but there are some possible other answers, and there's a little condition we're going to have to think about at the end, which is this. I'll come on to that. I'm actually going to focus first on all the solutions. Next up, b is 5, but when I minus 6 again, that's not going to be divisible by 4, or 61 minus 15 if you prefer. 7, we're going to get 40, and then we're going to get 10 girls here. Okay, so that works. For 9, we're going to get 34. That's not going to work. 11, going to get 28 and 7 girls. Running out of space, 13 is going to give 22. And then 15 is going to give 16. So 4 girls. Let me carry it on. So we could go up to 17 is not going to work. That would be 10 here. And then 19 would get to 4. There'd be 1 girl. Right, now what I've not done is ensure that we can have a whole number of teddies, because the number of teddies is a multiple of 3. But basically, when we add the number of boys and girls together, it has to be divisible by 3. So this was a possibility, but so this is going to be a new column. B plus G, I'm going to get 16, and that's not divisible by 3, so the answer can't be 13. Over here, when I add them, I'm going to get 17. No, it doesn't work. 11 and 7. That gives 18. So the number of teddies is going to be 6, and it all checks out. So the answer is going to be 7. Let's just show that the others don't work though. So then we'll just basically keep adding 1. So we get 19, and then over here we get 20. None of these are divisible by 3. And then if we carried on, you'd end up with a negative number of girls. So you'd also reject that. So this question has just been composed in such a lovely way. You get these different solutions for B and G, but actually there's a restriction at the start that you then have to check, and that is how we know the answer is 7. Brilliant.